mine says, follow path A, but my A's in red. What does it mean that my A's in red? It means not everyone has A. Who else has A? What do you have? You have D, okay. So you'll have to translate what I say into path D. It's the same logic thing. But you'll have to translate it. And all blocks are 120 meters on a side. So at least all our blocks are the same size. The following path A, and figure this, all blocks 200 meters on the side. I want to know the total distance and the magnitude and direction of the displacement from start to finish. So I'm going to grab a little picture of this so that I can, it'll help me in my vector diagramming. This one. Alrighty. So what I want to do is I do a vector diagram here of path A. So I know that distance is how far I travel, right? And displacement is how far I am from where I started. So if I'm doing path A here, my distance is going to be this vector and this vector. So I'm going to redraw those down here just to make them bigger. So I've got this vector and I've got that vector. And then my displacement will be from the beginning to the end. So it'll be that vector there. This would be the y, yep. That little drawing I did. That would be my y. And you're right, and even don't even really need to add any values in on it for technically it to be my y. Yeah. Since it put meters on next to the answer box, it's just looking for the value. All right. Ladies, just please keep it low enough so I can hear myself. Okay? And remember, we are recording, so don't say anything you don't want to be on the video. Okay? So you guys have it open on your phone and you're working on the problems, right? No, you have it open on the phone so you actually can try the problems, right? That'll be a good way not to fall behind. So, and then the other thing they want my direction north of east. So that may be the only part that I want to rethink how I draw this, because right now north is up this way. I'm going to rearrange my drawing here. All right? I'm going to rearrange my drawing in this fashion. I was hoping those were separate. That's too bad. I'm going to take that top one, I'm going to draw it down here, and I'm going to draw my other one up like that, because what is it, Thursday or Friday? Yeah, I know. Does it matter if I add the north to the east as compared to adding the east to the north? Does the order that I add things matter? No. So rather than thinking about my guy walking north and then east, I'm going to think of walking east and then north and getting to the same point. All right? Because they want my displacement, which is how long my green one is, but they also want the direction, they said, north of east. And this angle here, down here, that I'm going to label theta, is an angle that's north of east, because I start that east and I swing that many degrees north, right? So I would rearrange your vectors so that you easily have that angle within your triangle. I mean, it was easy enough to find it outside and then remember that they add up to 90 and everything. So you can use the other things you remember from geometry. I find it easier just to straight solve for it. So I'm going to call that path, that length A. Now let's see. They told me each block's 120 meters on the side. My northern is 3 blocks long at 120 meters on each block. That means my northern part is 360 meters. Right? Does that make sense? Yes, exactly. And then my easterly part is 1 block at 120 meters. Oh, so that's only 120 meters. Right? And so let's see, if I walk the red, so my distance is walking the red, which would be 360 meters plus 120 meters, which if I do it in my head is 480 meters. Well, I wonder if I got that right. Let's see. Let's see if I got that right. That's my distance, because remember, distance is how far I've walked. And yes, I did. Yay! I'm going to go back. I got more work to do. Now, depending upon your path, you may have more than 2 legs to do, right? Like your path D, you got more than 2 legs. Yes? I hit submit. No, it only submits things you change. So if you don't change it, it doesn't resubmit it. There's also some nice features on there, like if you click on the number 9 there, up top, it'll flip you right to that problem. And you can also, if you notice up top on the problem, some other little notes here, there's a thing that says previous answers. You know, you're going through, you've answered a bunch of times. Hey, did I answer 7? Did I try the number 7? You can click on previous answers. It will show you all the other submissions you did on that problem. If you're really stuck on one, you also have things over here that are, you can, so notice you can add your own notes to it. You can also put in things down here that say show my work. And you can also, if you hit ask your teacher on any problem, you can write me a little note, say, hey, I'm not getting this one, what am I doing wrong? Or, hey, I'd really love to see this one done in class on Tuesday. You know, so that's available on every question. All right, so, like if you had D here, so if you had D, you have 4 legs to add together, right? Ah, maybe you have a different path than me. What's your path? In your question, it says find the following values for path. Ah, you have a different path than me. I got the easy path. Yay. Now I need to figure out my green parts here. I have the 2 components. So I'm going to do, let's see, I have the 2 legs, and I want the hypotenuse of my right triangle here. SOHCAHTOA. No, Pythagoras. A squared plus B squared equals C squared. 360 meters. Let me get through mine, and then I'll show you the variations on yours, okay? Equals big A squared. And I solve for big A, right? And then I look up there and say, I got theta. I need to find theta. Theta is opposite over adjacent, right? So, TOA. Tan of theta is opposite over adjacent. My opposite is 360, so I'm going to do tan of theta is opposite 360 meters over adjacent. In my case, it's 120 meters. Then, I got to get theta out of the tan, so I'm going to do the opposite function of tan, which is arctan. Arctan of tan is theta. Arctan of this is using my shift key on my calculator, or my second key on my calculator, which means the same thing. And I can solve for theta. Now, as pointed out, I did have the easy one, right? So I know the person who asked for this had D, right? Sure. You know where a sign-up book is, right? There's no curves in any of them. That doesn't mean there's curves in there. So, let's take, for example, if you had path D, all right? In D, I'm going to look at, what I want to look at here in D is I'm not going to worry, did you get the path, did you get the distance you traveled? You count up how many blocks you walk. So path D, let's see, I walk 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I walked 13 blocks with path D, right? So can you figure out what your distance is? If you walk 13 blocks? Yes? I know, count it up. Start at the dot, count up how many blocks if you physically walk path D. Don't trust my number. You count it up also. I would. For D, maybe I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. For path D, I got 13 again. You cut the corner on me? I don't know. Count it up again. Now my displacement, okay? My displacement, I'm going to draw it right on here. I'm going to start where I start and end where I end. End right there. And now I'm going to look at, okay, that is 1, 2, 3, 4, 5 blocks that way, and 1, 2 blocks that way. So then I would grab that and move it down here. Oops. Of course, when I wanted it in 3 segments before, it was all together. So I said this was 5 blocks and 2 blocks. Right, and now I have my triangle like I had. And I can do the second part of it. That's the easiest way. And like if I had C, I'd draw it from the dot of C to the end of C. Oh, C has an easy displacement. Yeah? Huh, that's strange. Well, get a pass from me. I'll sign it, and then you can go to it and come back. So, we're going to do number 2 here. I'll tell you the most common mistake on this one is entering the northern component in the western spot and entering the western in the northern, flipping them by accident. I don't know why, but it is. So I've got a cheetah that's running at a speed of 15.3 meters per second. So I know that's the magnitude of my vector, and a direction 55 degrees north of west. So I'm going to draw a vector that points at 55 degrees north of west. And that would be this direction, roughly. And that says that here is 55 degrees, because I would start west and pull north. And it tells me it's 15.3 meters per second long. And I want to find out, this is number 2. Ah, yes, everyone's has different numbers. That anything in red is different for each user. That's the beauty of it. Follow along, but you got to do your own work. I love it. So, there's my vector diagram. That's what I would put for my y. Spin, you're all set on this one? Oh. All right. 15. So I need to find the horizontal component and the vertical component. I'm going to call the vertical one north because it points in the north, and the other one west because it points in the west. And so I look and I say, oh, I know the hypotenuse, I know the angle. I want to know, say, I want to know the opposite side and the adjacent side. So, to find the opposite side, I'm going to use SOHCAHTOA. Sine of 35 degrees equals the opposite side of, which I called n, over the hypotenuse, 15.3 meters per second. I'm going to rearrange that to solve for n. Bring the 15.3 meters per second over on the other side. Sine 35 degrees. That equals north. Just check online, Sean. It's all written down for you. So 15.3 sine 35. I get 8.78 meters per second. And I'm going to be risky because it's Friday and go on and do the adjacent side. The adjacent side is W, and adjacent uses cosine. Cosine 35 degrees equals adjacent W over 15.3 meters per second, which is my hypotenuse. I rearrange, I get 15.3 meters per second. Cosine 35 degrees equals W. So I get equals W. I get 12.5 meters per second. Now I gotta see if I got them right. Let's see. 8.78 for my north. Due north. 8.78 and 12.5 for my west. I got them both wrong. Oh, you know why? Because my angle isn't 35, it's 55. So I did that to demonstrate a typical student mistake. Welcome. I wrote my 5 and it looked like a 3 to me. So 5, so that's going to be off and that's going to be off. 15.3 sine 55. 12.5 meters per second. Oh, they're just going to be swift. Because I put in the complementary angle. And so they're just reversed. It's one of those mathy things. If you put in the complementary angle of yours like I did. No, I put in 35, which is the complementary angle of the angle it gave me, which is 55. 2,810 meters and 15 degrees. Paul, that's the whole point of this. With different numbers. Work in parallel. Alright, so number one, I'm given the length of the slope. I'm told it makes this angle with the horizontal, and I want to know the height of the mountain. So what I'm looking for, I'm going to draw it. I think I'll draw it this direction. There's the length of my slope. Told it makes 15 degrees, 2,810 meters. Yep. And I want to know the height. So what I'm going to do is do the components. Now that, technically, that would be enough for my y, right? Because that's the vector diagram they gave me. To do the problem, I'm going to add in the horizontal and vertical components to make a right triangle. But if you just had the green, I would give you full credit for your y. All right? Because you're representing, you're showing your understanding of it. I want to know the opposite. I'm going to call that h for the height of the mountain. And so I want to know the opposite side. I know the angle. I know the hypotenuse. Sine, right? So sine of 15 degrees equals opposite h over hypotenuse 2,810 meters. So I rearrange 2,810 meters times sine 15 degrees equals h. H equals $727 meters. You can always use your own paper to do the house lines, or you can use the ones I supply. 272, huh? Yep, unless the problem says, hey, answer to 566 or something. Yay!